Okay, I highlighted the circuit board because I was thinking, this board's almost the right size. It's also, but it's a little too big probably. But this is going to end up being a two-circuit board design. One for switches and the other for the LEDs. But we'll still have to see how that plays out. Excuse the background noise. I got a 3D print running an experiment. So let me go ahead, now that we got this part done, let's go ahead and scoot this up here where it belongs, with that other diffuser. Okay, so that's where that's going to be. And let me go ahead and, since I'm not sure about the circuit board yet, let me go ahead and grab this and copy it. I might use this later in one way, shape, form, or another. Let me go ahead and delete these two switches because they're not going to be there because there's the tube in the way. But this bottom, now normally when I do these designs I start from the bottom down. So I usually start with a battery holder and work my way up. But in this design, given the constraints of this diffuser, I'm probably going to start from the top and work my way down, but it's going to be a little awkward for me, so just kind of bear with me on that. So I got to start thinking about how we're going to encapsulate, this top part of the board. And remember, since this top cover is going to be a separate piece, it doesn't have to be the same thickness. That's why I'm kind of eyeballing this circuit board. Because if you recall, this is going to be our inner wall, and this is our outer wall, right? So the circuit board will be a little bigger than that, but that may actually be fine for what we're doing here. It just depends on how this whole thing materializes, and this is where it's going to get confusing, because remember, we got this track guide that we got to worry about. Which, like I said, I probably ought to go ahead and put this diffuser in its appropriate position before we proceed any further. That's probably the best thing to do. So I can put it in its retracted position. Until it says center. There we go. Okay, I don't think we need the cones on right now, so let me move that up there. I always put these at things like this at the top. And blank those out. And let me, again, put this in its retracted position. But, we still don't know exactly what retracted means yet. Oh, come on. It's going to be somewhere around here. We don't know exactly where, but it's going to be somewhere around there. So it depends on how thick I make this lid and everything, but I wanted to get this basically in its retracted position, especially before we start thinking about drawing any guides or anything. So, and that's where I want to position, because this is going to be the guide. However I make these guides, and this is going to be complicated, but however I make these guides, that's what's going to be subtracted, from this position. It's an easier drawing position, because I got to draw some kind of form or something, and it's subtracted from everything else. Probably that's probably how I'm going to do it. We'll see. But for right now, again, this circuit board is a pretty attractive proposition, because we know, okay, this by all means is going to be our in fact, since we're working on this, I'm going to go ahead, and I usually do things this way. I mean, you can actually adjust your coordinate system if you want, but in Rhino, but I usually just adjust my model instead. I'm going to go ahead and grab this from here, everything except that circle, and put it on elevator mode. So I've adjusted Whoops. Hold on, let me light up the cones. Gotta make sure all my layers are on before I do this. That's one of the drawbacks to it. So I'm going to go ahead and adjust this. Where it's down here, near our working plane. Oh, shite. Okay, well, like I said, turn the cones back off. Don't need them right now. But like I said, this, you know, whoops. Okay, this is the outer part of our housing. Okay, and we'll want that to be part of the cover. So now this piece, when we print, you know, this will actually be the bottom layer, and it'll print this direction. You know, this will be the top layer. In other words, this part will end up being upside down. So we'll get a nice flat mirror finish, you know, on the top of this, which looks nice. But the question is how thick to make it, and how are we going to do the bottom piece? Because that I'm still not sure about. Let me just do a test extrusion to see how things look right now going past that ring. So basically, you know, that's how the finished item might sort of look, except it'll be a little higher than that. But you can see kind of the clearances of this inner ring and everything like that. You know, we want to kind of keep that intact. You know, there'll be a little bit of play, you know, between this and this, so it'll be a little wibbly wobbly, which I'm trying to avoid, but you know, I can't avoid it completely in this case since we had to put this glue stopper here. I was just thinking that I could actually make it so it's removable. The whole assembly is removable, and I'm kind of considering that possibility, but you know, still I'd rather just do it this way. It's, you know, again, it's kind of hard to change your mind on a non-parametric CAD system, you know, because we'd have to redo all of the work. That's why, you know, when you're doing this kind of design work, it takes a lot more, you know, with a program like Rhino or most other just, you know, general purpose 3D CAD programs, you really got to think things out a lot ahead of time because of that fact that you could do hours of work, you know, doing a bunch of operations on a single part you're working on, and then have to go start all over again if you need to make a significant change to it, particularly if that's fundamental. I mean, it's, you know, it's pretty aggravating, you know. That's why a parametric CAD system like SolidWorks or Solid Edge is way better to use for things like this. But, you know, they tend to be expensive. I'm not aware of any cheap parametric CAD systems right now. There may be some out there, but I don't know. Okay, but like I said, where exactly we want this thing remains to be seen. Again, this is too low. I mean, in fact, it would be, you know, accounting for the thickness of the top of the lid, it would be probably more like there. You know, giving us an effect like that in final form. Again, this lid probably just needs to be a 1/16 of an inch. It's not going to bear a lot of, you know, a lot of force or anything like that. So it really doesn't have to be that thick walled. What I'd like to see for this circuit board is, and notice too how I have the standoffs on this LED a little bit above the circuit board, and that's because when you solder a circuit board, even with a hand soldering iron, it tends to expand. You know, the circuit board actually expands in thickness. So by the time, you know, you finish making your joints and the circuit board cools down, there's almost always a gap you know, even if the LED is right down to the board, it's almost always a small gap under it, a good 10 mil or more a lot of times. So, that's why I have some tolerance in that too, because I certainly wouldn't want to make a lid or anything like that and try to stick it on this thing and have it not fit, because the LEDs are actually, this distance here between the circuit board and the LED base is actually taller than I think. So again, that's why you want to have some loose tolerances even on that. Let me undo my repositioning of this though, because this is a good point to start with. Okay, what I want to do is I want to make this say 0.63, 0.06, 63 mil. So by doing that, that gives us a 1/16 of an inch lid. Now the thing is, though, is that I'd like to add some tolerance, at least another, especially due to layer discrepancy and everything. At least add another, instead of making it 63 mil, let's make it 73. Yeah, but say 78.078, just to give us a little bit more. Tolerance for error, because we'll make the wall thickness 63 mil, which is pretty exactly 1/16 of an inch. Now, having said that, let's see this cap. So we've got our circuit board there, and this right here, let me see how wide that is. I think I know what this is. Yeah, it's about 13 mil. It's about 26 mil. Because see, when I actually make my circuit boards, they're actually going to be a little smaller than this, because I've got a kind of a loose tolerance on my end mill. So the circuit board, whatever diameter it happens to be, is actually going to be a little smaller than this. But 13 mil on this circle here would be 26 mil total. That plus the discrepancy in the circuit board should give us enough allowance to where the board will fit. If not, you can always sand a circuit board down if you have to, belt sander or whatever. So it's not that big of a deal. So what I'll probably do is grab this little circle here. We'll just go ahead and reuse it, because that looks like a healthy tolerance to me. So I'll bring that down level with the circuit board. This is going to be our circuit board keeper. And again, we're probably going to do switch wells, just like I showed you in that other video, for this design as well. So because of that, that'll be part of it. Now, doing switch wells is pretty complicated. And there's certainly other ways I could hold this in, involving fasteners or what have you. But yeah, I think I'm going to do it this way. Muse on this for a second. Let's see. Got a switch well. I'm going to make use of this circle as well. Let's see, so this is going to be our lid right here. I'm going to want a lip on it that comes down to about here. So this can be kind of arbitrary, but I like to eyeball things. But I'd like the lip to go down. So this is 288 mil, so 300 and so that's 288, so about 380, about 400 or so. Maybe four, about right here will be fine. So I think that'll be probably our lid. again, this is the opposite way I normally work, so you know, just bear with me. But yeah, I think I'm going to use this here, which is not at a half bad position, but let me go ahead and just do this. Let's see what we have here. Yeah, because it's 78, 68. So 15 mil. So I'm going to move this down by 15 mil. Oops. Sorry. Move it up by 15 mil. So that should give us pull that out so it's straight. So that should be about a 1/16 of an inch right there. Yep, 0.63. So okay, so that's that piece. That's going to come out of the center, and that will clear our LEDs, as you can see, you know, between that and that. Then next, I want to let's see, I wonder how much space we got to work with here. I might need to shrink this circuit board, and it's okay if I do. You know, just give me a better well, but let's see. I got to pay attention to what's going on over here, though. For right now, I can go ahead and hide you know, diffuser and the lid, and where is that on? Oh, rain. Well, damn it. I need to be drawing on the top. Actually, so I'll change the object layer in those so I can hide the ring. All these concentric circles here, and keep track of what the hell they are. Okay, so this basically, you know, I think we can get rid of these right now. I'll go ahead and stick them on one of our use layers. But yeah, that's our outer lid there. But like I said, I might go ahead and shrink that circuit board, because I think we could use the extra space. And that circuit board from there to there, you know, we only got about 88 mil, and like I said, I can get away with less, but that means I'll have to make this top part thicker though, because I don't want it as thin as this, because I still want to capture it with a lid. So I want the lid acting like a positive hold down on it, so I can't shrink it too much and have it still clear our LEDs. In fact, that's a pretty minor, pretty small clearance right there. It's approximately 13 mil. It's pretty close. Let's see. Because see, the thing is that I'd like, let me think about this for a second. Because I could make the lid itself capture the circuit board, sort of. But see, why I like to have a bay, you know, is because of our switch wells. That's generally underneath. But actually our switch wells aren't going to go here, so what am I thinking? So actually, I could make the lid actually capture the LEDs then. And again, I'm thinking upside down here. This isn't the normal way I do, I design these LED products, so I'm thinking from the top down. It's a little confusing. Let's see. Since we're 3D printing it, though, I mean, I could actually have a little inlet here, so the LED has a space to go. In the lid, I don't think that would be a problem. So yeah, I think I can decrease the size of this a little bit, probably to at least there, which is another 20 or 30 mil or so, but I may not need to if we're just going to capture the circuit board with the top. Let me think about this for a second, because like I said, I definitely want a skirt coming down the side, kind of like we have here, about this distance. But that skirt actually could almost be based on this that circle instead, and this LED board can go in. The LEDs will actually hold the position of the board so it doesn't rotate or anything. I generally wanted to just keep that side to 1/16 of an inch. Well, I'll tell you what. Okay, so this is our outside, right? So let me go in and draw a circle. Okay, but instead of it being a diameter 1.701, I want to subtract. Some CAD systems you can actually do the math right in the damn entry bar, but I don't think you can do it with this. Let me try it. 1.701 minus 2 times 0.063, because we want to take off the diameter. See if it did that. No, it's 44 mil. If it did, it miscalculated it. Or actually, I might have been reading the thing wrong. Let me try that again. Okay, so this is, no, it's 1.701. So but yeah, that's 613 or whatever is not the end result. Yeah, it's not doing it. I don't know what it's doing, but like I said, some CAD systems you can actually type in an equation, which will make it so much simpler. Thought you could do that. Maybe there's some special character you use or something. I don't know. It's not working. Son of a bitch. Anyway, fuck that. Let me go in and make this 0.063. Okay, because I don't want that wall any thicker than that. So, Let me move that to the bottom. Well, let me just move it down here. Okay, so ideally, like I said, what we'd actually like to have is that come up to the bottom of our circuit board. And, well, I'm going to leave that. And we want our circuit board to actually fill that out. I don't know what the discrepancy is between the two. It's only about 24 mil. I mean, that's okay. It's a little loose on the tolerance. Well, let me make it just a little, the circuit board just a little bit bigger in diameter. I'll bring it out to our old circle there, so that gives us a little tighter of a tolerance on it of about 11 mil per side. Well, keepers. Put it about right there. Again, like I said, the circuit board's going to be a little smaller than this anyway in practice, so I'm not that worried about it. Okay, so now that I got that done, let's go and draw us some circles. Now this is going to actually cut through it, so like I said before, that's about 200 mil, so let's make it about 228 or so. Okay, I'm going to move that up there and stretch it there. Okay, I'll copy this and center that to the center of that, and select the last object created, and then let's go do one of these things. Circular array. Okay, now let's do our Boolean subtractions. We'll start with this one, and then we'll do this one, and then we'll do this one. Okay, so now we have this thing carved out, as you can see. Now I don't know whether I'm going to put any resistors on there or not, but I might. You know, if we got the extra real estate, that'll make our other circuit board smaller, the one that carries the switches. So we'll see. I haven't decided on that yet. Anyway, so that pretty much. What the heck is that? It's not necessary. Go ahead. Now usually I try to use this layer for objects and this layer for like curves and lines, but anyway, so basically when we make the circuit board, we'll just, you know, it will, you know, we'll populate with LEDs and just stick it in there and align it with the holes, and that'll hold it, and then this will, you know, be fastened down and glued to some sort of carrier. Now the thing about it is, though, is that's not very much distance. It's probably not a problem though, but I kind of like having more to work with in this, because this is you know, almost 1.5/16. You know, but I should have made that part a little longer so we'd have more surface to glue to, but I don't think it'll be a problem. Muse on that for a second, but yeah, I don't think it'll be a problem. Anyway, this part of it, you know, this lid is certainly not going to have our you know, our ring is going to come nowhere near the lid. I mean, we're not going to end up with a crack in. Oh, that's what that line was. Yikes. that line was. Let me grab that and keep it. Use the redo key. This thing doesn't undo and redo everything. I'm going to put this in the cones layer so we don't lose it in the future. But yeah, like I said, you know, this is going to be the maximum height, and I'm certain we're going to make this this tube less tall than this before too long, but that's getting ahead of ourselves. Let's continue with what we're doing for the moment. But you know, anyway, the reason I brought that up is because I don't think that little slider, you know, it's not going to go into this piece. I mean, we're not going to have a track in this piece of it. So, you know, that's going to be well below, you know, what we're going to be dealing with. So we're okay with these wall thicknesses. We don't have to worry about some piece having to slide through here. And when we do our switch circuit board, that'll be below that track position, much as it's shown here. I mean, it'll be below the rings because, you know, under no circumstances do you want your switch to be inaccessible because some plastic, tube is covering the switch up, even if it would be possible to slide it over the switch. But okay, so but that's got our basic carrier for the top made. Now I'm going to have to make a another piece for the bottom that actually complements this. You know, it will have a little wall that goes up in it, but I got to think about this for a while, so I'll break off the tape here and tell you what I decided, so I don't bore you with my